Hey math fans, we're on section 3.1.1. Let's get started. In this section, we're going to learn all about the properties of algebra. So let's start off with the properties of equality. The first one here is the reflexive property, where if you have a number, let's say a, it's going to be equal to itself. It doesn't really come into play too much in algebra, but definitely when we get to geometry, it does. You have the symmetric property. It doesn't matter which side of the equal sign a number is. If a is equal to b, b will be equal to a. The transitive property, if a is equal to b, b is equal to c, a is equal to c. I think of it like a train. It's kind of like a is really linked to c. It's like a train. Sometimes I call it the transitive property. That's a bad joke. Okay, and then you have the addition property and subtraction property. Those are probably the ones that we use the most, along with the multiplication and the division property of equality. Those four properties together are definitely used the most. We also use substitution quite frequently when we are graphing and making a table. If a is equal to b, then b may be substituted for a anywhere in the equation. And that brings us to the properties of operations. The two that get confused the most are the commutative and the associative. They look pretty similar, but in actuality, notice that this one has grouping symbols. And the way I like to think about it is the word association, which is very close to associative. An association is kind of like a group, and it deals with how you group things. And in this particular case, it doesn't matter if you want to group the 3 and the 8 first, or if you want to group the 2 and the 8, they're still going to be equal. So I think associative, I think grouping, brackets or parentheses. Commutative property is much like a morning commute. A plus B, and then you got B, it's kind of like you go to work and then you come home. A plus B equals B plus A. And here are the different ones as they work with the properties of multiplication, and then we also, of course, this one you guys are super familiar with, the distributive property. Okay, so let's use some of these properties. Which property of equality is missing in the steps to solve the equation negative 7x plus 22 equals 50? So no longer do I want us to just solve the equation anymore. I want you to think, why is it that we can go from step 1 to step 2? Why is it that we can go from step 2 to step 3? I already know you guys know how to solve, but what are the reasons? So we're going to have a statement column and then a reason column. When you get to geometry, this is also known as a 2-column proof. Now, there really is no reason for step 1 because it's the original equation. When you get to geometry, oftentimes you will see them write the word given as the first reason. So what happened basically between this step and this step? Well, it looks like all of a sudden this 22 is no longer there. In fact, doesn't it look like it got subtracted from both sides? What do we call that? Yes, we call that the subtraction property of equality. And then what's happening from here to here is, aren't we dividing by negative 7? Dividing by negative 7, so that will be the division property of equality. Which property of equality is missing in the steps for the equation negative 3 minus x over 6 equals 4? So the first step is obviously going to be that original equation, or you could write the word given. But what's happening next? It's almost like we lost this negative 3. Now be careful. We really didn't subtract 3 from both sides. Aren't we adding 3 to both sides? And that's how we get the 7. So the next step is really going to be the addition property of equality. And then what's happening? Here we're dividing by 6, which means if I really want to isolate the variable, wouldn't I multiply or do the inverse times both sides? Aren't I multiplying both sides by 6? And that's what's going to get us to 42. So the next step should be multiplication property of equality, followed then by division property, because really we're dividing by -1. I will accept also multiplication, because you could be multiplying by -1 to get to the final answer. Multiplication and division are pretty much the same thing. It's like you're multiplying by a reciprocal, but I will accept either of those answers. All right, example 3, which property of equality is missing in the steps? And I think we're just going to go through all of it here. Take a moment, pause the video. How are we getting from step 1 to step 2? First of all, the first step is always the original equation, followed by, that's right, that's the commutative property. Notice that we really didn't do anything. We kind of just switched the order. And so if we're switching the order, that is called the commutative property. Well, why not the associative property? Well, because there were no grouping symbols. There was no parentheses. So it's going to be the commutative property. A lot of people will skip this step and just kind of move to the third step. Now, the book calls it the distributive property. I would just say I would say just combines like terms. We're really not doing anything to both sides. We're just kind of combining. And if you want to look at it as the distributive property, that's fine too. But I would just call it combining like terms, followed by, it looks like we're what? Adding 15 to both sides. So that should be the addition property of equality. And then we have division, correct? We're dividing by 7. 91 divided by 7 is 13. And finally, take a look at the last one. What do we call it when we are kind of switching places? Now, the commutative property just deals with one side, but when we actually flip on which side of the equal, we put the left on the right, that is called the, does anyone remember? Symmetric property of equality is where you switch. A is equal to B, and then we switch it to B is equal to A. And that's going to do it for this section. We'll see you in class.